Okay. Hey, everybody.
Hey guys.
Hello.
All right. I think we're going to talk about Lambda scaling today.
Yep, that's the topic. Do you just want me to kick it off and start speaking, or do you want to set it up a little bit?
I think I want to kind of set it up. We'll talk about it, the kind of the context of this. Yeah. So me and Dustin, primarily Dustin's been working with one of our longtime customers called Backers. And last year we started on a kind of like a modernization journey for the serverless environment in AWS. Just to give you some backdrop, essentially for most of 2 years now, the Backers environment has been kind of like all located in the single VPC, right, for staging and production, and that has become kind of a bottleneck for the speed of kind of iteration and performance scaling. And I should say Scott and Dustin led and have been leading the sort of like breaking up of that monolith of AWS into discrete environments that are like dev, staging, and prod. Very clear, very clean separation, each with its own VPC, and so that you have much better security and much better uh, uh, sort of isolated changes between the environments that don't kind of leak over. So that's the backdrop that has been evolving uh, from the late part of last year, this year. And so, yeah, Dustin, and maybe you could kind of describe the state of how we managed the Lambda pool last year versus what you tried to do this year.
Mm-hmm. Yeah. So last year and even the year leading up to that, we were still in the product was still in a rapid development, rapid prototyping kind of state, right? Where everything was, let's deliver as fast as possible. And a lot of optimizations were kind of left on the floor for, time reasons. So that left us with the way our Lambdas and scaling happened was kind of like a default state, right? Like the great thing about Lambdas is it allows you to spin up more instances as more traffic comes to your site, right? Or to your service. The problem, well, the innate issue with that is that as your traffic increases and you have to split more Lambdas, there's time involved, right? So very quickly, as our user base grew, more and more users were complaining about the performance of the app, right? 10 users would get on, and then another 20 users would get on, and those additional 10 users would notice my app is very, very slow, right? And that's just due to the Lambdas having to have time to spool up. And that's all built into AWS, and that's great. Those Lambdas, once they're spooled up, they stay alive and warm for a certain amount of time so they can be reused. So that boot up time isn't incurred again, right? Until traffic dies down, the Lambdas slowly scale in back down to its default, setting. So our initial way to handle this was, well, let's bump up the number of Lambdas that are immediately available at all times, right? And this is kind of the naive approach to increasing performance and reducing boot up times. Instead of having 100 Lambdas or 10 Lambdas available at a time, you say, I'm just going to make 100 Lambdas available at all times, right? So you kind of guess, okay, I think our peak usage is going to be this, and that's going to require 100 Lambdas, and we're just going to run that. It works. Our performance issues dropped dramatically, right? And we were able to solve that problem. The issue with that approach is that requires these 100 Lambdas to be running at all times, right? And you're incurring that cost, right, per minute of I forget what the exact metrics, it was like per minute gigabyte use of these Lambdas, right? And that adds up over time, especially if our goal is to scale up to 100,000 and a million users, that's going to get expensive very quickly. We briefly talked about exploring how can we auto scale this so we don't always have 100 running, right? And that was floored because of time reasons. Luckily, this kind of need to restructure our infrastructure to give us these separate environments was, okay, now we have a separate dev space that will allow us to play around with this for a little bit and actually explore that. And so luckily, the actual process of managing like auto scaling, provisioning of these Lambdas is not that difficult. It's actually a service that, or a mechanism that AWS has built into Lambdas or available for Lambdas. It's application auto scaling. And the short story of it is you can configure your Lambda to behave in a certain way, where as traffic increases, you can increase automatically the amount of Lambdas that are warmed up and available, right? So as more traffic comes up, AWS will recognize, hey, I need to have more warm Lambdas for a certain period of time. So it'll say, I'm going to kick this up from 10 Lambdas up to 50 Lambdas, right? And then if traffic increases again, it'll recalculate and say, okay, now we're going to need 80 Lambdas to handle this traffic. And then it'll step down eventually as traffic dies down back to its resting state or its default state, however that's configured. The big benefit of that is, of course, now you get to handle peak usage, right, with minimal wait times and boot up times. But also once traffic is slow, right, you're not paying for the 100 Lambdas that you required for your peak times, right? So you can rest at, your slow times for 50 Lambdas, 20 Lambdas, whatever that is. And you save cost kind of automatically with a pretty elegant, automatic solution, right?
Well, I mean, I think that even though the change is simple, it's pretty telling, in my opinion, that we were so conservative about any of these infrastructural changes. So that's just one of the infrastructural changes that we could have done, right? Never mind all the other more radical changes, like changing transcoder and all the business we were doing, right?
Yeah.
Too scary to do in the combined environment. In fact, almost impossible to do without incurring cost. But even like you said, it was pretty, it's pretty standard, but actually having, right, that development environment, integrated development environment, like frees up your CPU of courage.
100%. Because really quickly, the side quest on that is with the two deployed environments that we had available to us, right? Like you can't really mess with prod until you've tested it in some kind of development environment. Well, our development environment was staging, and staging was active being used by the product team to sell, right? So that was limited downtime. Like we couldn't really mess that up in a significant way, right? Without risking momentum on the sales and product side, because they needed that to develop the app, and the business direction of where they were going. So we didn't have the luxury of mucking about, with the way things were working. So it was, if it's working, don't touch it, was essentially the SOP.
And never mind the sales activity happening on the staging server. It was like we had to be very cautious about the staging environment because we couldn't destabilize that with. We could not destabilize that because we might need to push to production at any given point.
Yes, 100%.
So I mean, I guess this podcast right now is kind of about both things, right? Is having the correct environments and making the investment to make that is going to have sort of like bears fruit for a long time now. We can like just generally improve the whole state of affairs. So including this auto scaling thing.
Yep. Yeah. So those were kind of like the business and practical reasons on why we waited and why it's going to be beneficial now. But there's also the developer side where you're like, why are we manually having to configure this concurrency issue, right? Because we would have these onboarding events, right? And our CTO would say, hey, we're having an onboarding event. I need to go into the staging or the production environment and manually set the provision concurrency to a higher number, right? So we could handle a number of users and not have to worry about, the app not running when needed. And then they'd have to remember to go back and turn it, dial it down. And, that kind of manual stuff kind of bugs you. And you're like, I know there's a better way to do it. And that kind of drove the side quest to get the auto scaling in just from a dev way. You want to kind of like optimize it.
Okay, naively, when you think about AWS Lambda, you think, oh, it auto scales. When you call, if you make more calls to the Lambda,
Mhm.
you're going to get, more instances of the Lambda to handle requests.
Right.
What is different about this setup?
So, first let's talk about concurrency in general in AWS, right? So you have a Lambda, your default account or your account in general has a certain number of instances that you're allowed of any Lambda instance that you're allowed to spin up, right? So you've got a bucket of instances that you're allowed to have running at any one time.
Right.
So there's different ways you can manage that between your Lambdas. Let's say you've got your, we have a big Lambda for our service, right? That handles all of our routing and the business logic, right? We want to make sure that has a high availability. So we're going to set something called reserved concurrency, right? That effectively blocks out a chunk of our availability to say only app Lambda can use this bucket, right? And it'll pull, so that means everything else is limited to 800. Let's say you've got 1,000 instances that you can have. Everything else, you only have 800 of those, right? So you can kind of control how much they've got there. So the auto scaling or the normal scaling, like when a Lambda spools up, it'll say, okay, one Lambda is busy. I've got another request. I'm going to spin up another Lambda, right? And such. And it grows like that. But again, there's those tiny little boot up times, right? Like it's going good. And then new request, a little bit of time. And now I've got 2 Lambdas, right? And then another few seconds. Now I've got 3 Lambdas, et cetera. So the growth is slow. Provision concurrency, right? That is, again, like I said, you are allowed to say, I want 20 of these Lambdas to be running at all times. Once you go above, let's say you've got 20 instances running and then you need 10 more, right? It's going to default back to its standard way of let's create 10 more Lambdas the slow way, right? Or we're going to create 10 at one time or whatever, but there's still a time after those first 20. The provisioned auto scaling is slightly different, right? So what's happening is when you configure this auto scaling capability, you set an alarm on that Lambda, right? So CloudWatch is now listening to some metrics on that Lambda, right? And there's different ways to do it, but let's just say we set it to listen for once I hit 20 Lambdas, right? I want more, right? So it's going to run an algorithm to say, here's the amount of traffic I have. I need to make sure that I've got any number of Lambdas available at all times to handle this traffic, right? We go by a usage. We want to say, we always want to have 40% buffer between what we have available and what our actual usage is, right? So CloudWatch is doing its calculations and crunched all the numbers and says, an alarm goes off. Oh, we've gone beyond a certain threshold. Let's get some more reserved concurrent or more provisioned concurrency up. So it'll spin up. It'll say, instead of I need 1, it'll say, oh, I need 20 warm Lambdas now to handle this traffic that I'm currently experiencing, right? So it'll spool those up. And now that is the amount of warm Lambdas that you have. Once you go beyond that, for let's say you have a massive spike, it'll go back to the standard scaling and say, okay, now we're doing the onesie twosie thing, right? And there's different max and min ceilings that you can even set to say, I only ever want to have 250 of these, or a minimum of 50, right? To kind of give yourself a nice window. So it's very elegant. The configuration, we use the serverless framework. So there's a plugin that manages this, and literally it's as simple as saying, here's my usage metric that I want to keep, my target, a minimum, maximum. So here in this, we can see, here's the app that we're targeting, right? We've got a provision concurrency value set, for prod. Let's just say we're targeting 100,000 users. We used a Claude and Cursor to kind of help us come up with these baselines that we're going to start with. But we're going to say, okay, we've got 80 Lambdas that we want to target. But here in our concurrency auto scaling, this is managed by a plugin which I forgot to capture. Um, but you can configure, here's all the configurations here. So you can set a minimum and then your maximum. Your usage target is a percentage. So you always want to be using 70% of your provision concurrency. Again, right? So let's say we set 100 is our target. If we set a usage of 70 or 70%, the baseline, right? It's gonna try to have 70 running, right? Or 70% of that, until all of a sudden you've got a whole bunch of requests coming in. Once you hit 70%, it's going to measure and calculate the number of Lambdas you need to have to maintain that 70% usage, right? So there's always that 30% buffer that you have, right? And so you can adjust those per environment, to be safer, more conservative, or more aggressive about your availability. Yep. This custom metric allows you to just change the way that is calculated. Maximum means anytime we hit in number of, anytime we hit 70%, no matter what, it's going to trigger the scale out, or an average, and it'll measure over a trailing 3-minute period what is the average usage, and it'll use that as the metric to scale up and down. So, I mean, fairly simple configuration, and I haven't done any sort of usage or calculation costs, but I mean, the amount of Lambdas that we're going to have spun up at any one time, over the long run, is going to be greatly reduced across all of our environments.
Yep. Much less fat fingering too that could happen when you're doing it manually.
Yes.
Nice. Yeah. So before, this was not managed in code. It was more in a manual way.
Yep. It was the manual way. There's a whole other topic on the way AWS uses aliases to help facilitate this concurrency, but we were automatically managing our aliases and our Lambda versions that we were pointing to and stuff like that. This configuration just manages everything automatically.
Very cool.
Thank you. Thanks, Dustin.
Mm-hmm.
Nice. Any last questions here about what we've done and its context?
What do you think this will allow you to do in the future? Or does this open up any new possibilities?
Well, probably the big one is when Beaverton School District harasses the webpage all at once, we should be able to not, forget to set the right amount and it'll still stand up and provide a great experience, right?
Yeah. It's 100% security, right? Like it's once this is set, we can trust that we're always going to have, the appropriate amount of resources to give us the performance that we want.
Yeah. You don't have to have a human watching it or knowing Beaverton's going to have a big spike.
Yes.
And
yes.
Remember to turn it off because it's costing you thousands of dollars to have it there. I should have turned that off, right? No, it needs to gone by.
I know for a fact with the, we want to grow, but with our small user base right now, there's no reason that we need, the amount of Lambdas that we have running currently, right? But that's hard to gauge. That's hard to measure, and it's something you'd have to constantly be going back to. This now, it's kind of set it and forget it.
Well, thank you, Dustin and Josh and Scott. I think that we're at time, and thanks for this mini exploration.
Yeah, it was a blast to implement, and it's fun to talk about because I'm right in there. So
yeah, thank you.
All right, thanks. Take care.
Bye, everybody.